7, 6, 5, 4, 3, 2, 1. Liftoff.
Visibility was quite low on the morning of March 30th, 2021, when SpaceX lifted Starship serial number 11 off the ground on its first attempt of trying to leave the surface of the Earth. The fog rolled in thick, and even from the engine skirt camera, beyond the Starship you can't see anything but vapor at this altitude. One of the engines did catch fire here in a place that it's not supposed to, and Elon did confirm that Engine 2 had issues on ascent. Here we get a quick glimpse of a camera inside of the Starship looking at some of that super cold propellant that's being pumped into the engines and burnt and forced downwards to provide thrust pushing the Starship upwards. At this point, the Starship has gotten to about 4 kilometers in altitude and continues its journey upwards to an apogee of around 10 kilometers, which is in the general area that airplanes fly. You may notice that the exhaust underneath the Starship looks a bit brown in color. And that's not abnormal for a Starship test flight because not only can methane burn a little bit on the brown side, but upon liftoff, the Starship is also pushing up lots of dust from the ground, and the reason why it's highlighted here is because of that white fog underneath that dust plume, creating the contrast. So the good news is that even on a very foggy day, we did get some really great views from this Starship serial number 11 onboard camera. Once the Starship got above the fog line, they were able to show us these beautiful shots of the Starship ascending into the sky. The bad news is that SpaceX didn't have a lot of luck receiving these camera feeds at their headquarters. These are of course wireless transmissions, and anything that's wireless can be subject to dropouts. The feed we're currently looking at is holding steady for now, but as soon as it drops out, we'll fast forward and you'll see the timestamp jump on the bottom left. There were a few wins and very nice things that happened with this test flight. First of all, it launched as scheduled, right when they said it was going to launch after they got permission from the FAA. They didn't have any automatic Raptor aborts, they didn't have any launch pad delays, and that's a big step forward for the Raptor engine, which is very important. Here we're going to watch 3 engines hand off the responsibility of pushing the vehicle upwards to just 2 engines, and they move around to keep the thrust vector pointing in the right direction to keep the vehicle balanced and the flight on the right trajectory, which of course at this point is straight upwards. Now I'd like to note that SN8 and SN9 handed off from 3 engines to 2 engines before the 2-minute mark, but SN11 here handed off at about the same time that SN10 did, at around 2 minutes and 15 seconds into the flight. Unfortunately, in this video, we don't get to see the 2-engine to 1-engine handoff, we don't get to see the belly flop maneuver, and we don't get to see too much of what the Starship looked like while it was falling because the ground cameras were blocked by fog. At this point in the flight, Starship SN11 has reached about 8 kilometers in altitude and is getting ready to perform the handoff from 2 engines of powered flight to just 1. So this is where the video problems really start. The camera you're looking at has now been frozen. The SpaceX video production team tries to switch to a multi-feed, but that doesn't work. And then they just go to a shot inside the engine bay where you can see the thrust handoff has already happened. The one engine that is still firing has a wide plume because the Starship is now high enough into the atmosphere that the ambient air pressure around the vehicle is now low enough to not be pushing inwards on the plume as much as it was before. So after this shot froze up, the SpaceX official feed showed a black screen for almost a full minute. During that time, at about T+4 minutes, the Starship did get up to 10 kilometers in altitude. Shortly afterwards, it had a successful belly flop maneuver, and it started its slow, controlled descent back towards the surface of the Earth in Starbase, Texas. When we did get back to a feed of SN11 after the belly flop maneuver, it was interesting to see that there are now 2 cameras in the engine bay. We saw the first camera shortly after liftoff, which would now be facing right side up, but during the belly flop maneuver, the camera on the other side of the engine bay is now facing with the Earth on the top of your screen and the sky at the bottom of your screen. At about 4 minutes and 50 seconds, we got a stable video feed again of the belly flop skydiver maneuver in progress. We're now looking at the aft flap on what I would call the port side of the Starship, and you can really see what a beautiful morning it is shortly after dawn here in Texas. All of the flight profiles for the Starship prototypes so far have had a much quicker descent than ascent, so yes, it does fall slower than it ascends. But you have to remember that the whole idea of this, and the whole reason that it has flaps, is so that it can control its descent and make it a much slower descent than it would be if it were just falling feet first, like the Falcon 9 booster does while it's pencil diving. So now we're within 2 kilometers from the ground, and we've switched inside the engine bay to look at this camera facing the engines for the landing burn. But unfortunately, this camera does not last long, and neither does Starship Test Vehicle number 11. You'll see the engines gimbal out to make room for each other, just like they did on SN8, 9, and 10, and then within half of a second of that first engine firing, the video feed freezes and remains frozen for the remainder of the SpaceX official feed. There has been some speculation that the engine on the right-hand side of your screen had a thrust vector control failure and was locked into place right as the landing burn was supposed to fire up. The only other flight that attempted a 3-engine fire-up was SN10, which fired each engine in succession, 1, 2, and 3. We didn't get to see if SN11 was able to fire more than one engine at all because the video feed froze immediately after the first engine lit up, and the entire vehicle was lost shortly thereafter. Big shout out to Everyday Astronaut for providing this footage of debris falling, and shout out to Elon Musk for hopping on Twitter to give us some updates right after the test flight. As mentioned before, it looked like Engine 2 had some issues on ascent, and he said that it didn't reach operating chamber pressure during the landing burn, which in theory wasn't needed, but then he said something significant happened shortly after the landing burn start, and they should know what that was once they can examine the bits. It's super exciting to know that serial number 15 will roll out to the launch pad in a few days. They're of course skipping 12, 13, and 14 because they're literally making starships faster than they can launch them, and serial number 15 has all of these design improvements. Hopefully one of these improvements covers the problem. If not, then they'll retrofit and will add more in a few days, according to Elon Musk. It's really exciting to hear about the next major technology revision, which is going to be at serial number 20. Those ships will be orbit capable with heat shield and stage separation. Ascent success probability is high. However, SN20 Plus vehicles will probably need many flight attempts to survive Mach 25 entry heating and land intact. Of course, to go to space, it's not really that hard, but to stay in space, you have to get into orbit and go really, really fast. And to come back from space is even harder than that because you have to enter the atmosphere and slow down enough to land safely. Moving on to Super Heavy, I'm super excited about Super Heavy boosters, which are a very important piece of the puzzle when it comes to getting a Starship actually to space. Elon says that BN1 is a manufacturing pathfinder, so it will be scrapped. We learned a lot, but we've already changed design to BN2. So that makes a lot of sense. The Super Heavy booster is a huge, gargantuan piece of hardware. There's actually never been a booster that large in the history of humans building rockets and spaceships. So they put together booster number 1 just to figure out how to put one together, and now they've learned a lot and are going to change the design for booster number 2. The goal is to get booster number 2 with engines on the orbital pad before the end of April, and it might even be orbit capable if they're lucky. What an exciting time to watch what SpaceX is doing as they develop the systems to move humanity into the future and bring humans to space for super cheap and super often. I'm Mike DeRosa from the Small Stars channel. Please select the like button and hit the subscribe button if you haven't already, and check out our Patreon if you want to throw in $1. Open your mind and reach for the stars.